Hello everyone, welcome to the third video of the playlist where we are solving the past 20 years JEE Advanced question. Okay, so right from 2006 to 2025 we will solve every single question which has been asked in IIT JEE or JEE Advanced. Okay, so this is the third video and this question was asked in JEE Advanced 2024. So it is given that there is a block of mass 5 kg moves along the x direction subject to some force which is a function of x with value of x in the meter. At time t equal to 0 it is at position x equals to 1 meter. The position and momentum of the block at t equal to pi by 4 second r. Cool. So okay, first you can pause the video here and try to solve this question, and once your attempt will be done you can again resume it. Okay, so cool. So it is given force is minus 20x plus 10, and also mass is given, so we can say acceleration is given. Basically acceleration is given minus 4x plus 2. I have just divided it by mass. Okay, so acceleration is given in x direction. What I can do, I need position and velocity, right? Position and momentum is nothing but velocity into mass. So we need at particular time, so we need position and velocity as a function of time. So what I need x as a function of time and I need velocity as a function of time. Okay, if I write acceleration as a function of x, if I write acceleration as v dv by dx, I hope everyone knows we can write acceleration as v dv by dx. Okay, for the students who have just entered in class 11, acceleration is nothing but dv by dt. If we multiply and divide by dx, we can write it as dv by dx into dx by dt. Okay, dx by dt is nothing but velocity, so it is v dv by dx. Same thing. Okay, so acceleration, we can write acceleration as v dv by dx is equal to minus 4x plus 2. If we will solve this, if we will integrate, will this help us? This will not help us. Why this will not help us? This will give us velocity as a function of x and there will be no time. So actually we need x as a function of time t and velocity as a function of time t. So this approach will not help. Okay, so I am just erasing this to save my space. Okay, acceleration is 4. Okay, cool. What other thing we can do is we need time, so we can rewrite acceleration as dv by dt, and dv by dt is nothing but d by dt of dx by dt. Okay, so this is double differentiation, so acceleration is nothing but d2x by dt2. Okay, so if I rewrite acceleration as d2x by dt2, d2x by dt2 is equals to minus 4x plus 2. Can we solve this question? Can we solve this equation? Okay, since in engineering first year we have this subject engineering mathematics, and there we learn how to solve this kind of differential equation. I think this is also in this class 11th or 12th. I do not remember, like I do not teach mathematics, so I am not well aware, but I think I don't know. Okay, so how we will solve this? Looks like something like SHM. Why looks like an SHM? Because double differentiation of something is directly proportional to that function itself. Okay, so this definitely looks like an SHM, but this constant is some pain. Okay, this is giving us some pain. So how we can solve this? So there is minus. Okay, there is minus, so it looks like an SHM minus kx plus some constant force. Okay, 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 okay. So I think I'm not well aware about the mathematics course, okay, for JEE Advanced syllabus, but I think solving this equation by a traditional method is beyond the scope of class 12. But JEE committee will definitely expect us to visualize or visualize things in a way which will favor us. Okay. So what I'm saying is this: what if what if instead of visualizing this thing, this force in x direction, what if we visualize this in y direction? Okay, if we will see it in y direction, so there is some force which is in opposite direction minus 20x, and there is some constant force. Okay, so does this look like an spring mass system in the vertical direction? Why I am saying so? Because in vertical direction there is always some constant force mg, and then there is some spring force which is which is in the opposite direction of displacement. Okay, so this minus 20 is indicating this minus and this x, this is indicating, this is giving us hint that okay, there is a spring, and this constant force is giving this constant term is giving us a hint towards the gravity. Okay, so what if we visualize some other system in the vertical direction where spring constant is minus 20, where spring constant is minus 20, and instead of gravitational force there is some other constant force which has value 10, and we don't care, we really don't care whether it is gravity, whether it is something else. Okay, because originally it was not in vertical direction, it was originally in horizontal direction. So we just have to imagine this in the vertical direction, and we can compare it. Okay, so now definitely this system looks like an vertical SHM, right? This system looks like an vertical SHM. Okay, now this is quite easy for us. Okay, what we gonna do is we gonna find the equilibrium position. Equilibrium position is what? Where force is 0, where acceleration is 0. So minus 20x plus 10, this is force, this should be 0. Okay, so x will be 1 by 2, right? X will be 1 by 2, which is 0.5. So if I write, this is my equilibrium position where x is equals to 1 by 2. Okay, cool. Also there was something given at x is equals to 1, it was at rest. Okay, at x equals to 1 it was at rest. So we can say x is equal to 1 by 2 is this, x is equals to 1 will be this. Okay, x is equal to 1 will be this, and it is at rest. So this is one of the extreme position, what we call extreme position SHM. I forgot, it doesn't matter. This is one of the extreme position. What will be the another extreme? So this is 0.5, this is 1. So another extreme will be 0, right? Another extreme will be 0. X is equals to 0 will be another extreme. Fine. Now we are happy. Okay, what is the value of k here? K is 20. We just have to compare. Okay, force is equals to minus kx plus mg. This is the equation of spring mass system in vertical direction. So just by comparison, can we say k is 20? K is 20. So what will be the acceleration? Force is equals to kx. I forgot, wait. So acceleration, if I rewrite, k is equals to m omega square x, right? M omega square x. So omega equal to root k by m. Omega is root k by m. Fine. Omega is root k by m. So I know k is 20 and m is given to us. What was m? M was 5. Okay, k is 20, m is 5. So omega is root 20 by 5, which is 2. Okay, so omega is 2. Omega is 2. And for this SHM, if I write a general SHM, how it looks like, x is equals to a sine omega t plus some constant. Okay, so how we can write it? Omega is known to me, a sine 2t plus c. Okay, also we can figure out the value of a. A is nothing but amplitude, right? The difference between equilibrium and extreme position, so which is 1 by 2. So I can write it, x is equals to a is nothing but amplitude, difference between equilibrium and extreme position, which is 0 minus 1 by 2, 1 by 2. So 1 by 2 sine 2t plus c. Okay, actually it should be some phase as well, there should be some phase difference as well, sine 2t plus 5 plus c, a generic equation. Okay, now it was given that at t equal to 0 it is at x equals to 1 meter. So we will put t equal to 0 to figure out the value of phi. At t equals to 0, x is equals to 1 meter. Okay, at t equals to 0, at t equals to 0, it is at 1 meter. Okay, so x equals to 1 by 2 sine phi plus c. At t equals to 0, x is equals to 1. At t equals to 0, x is equal to 1. This is given. Anything else is given? So 1 by 2 sine phi plus c. Okay. What will be the maximum value of this term? 1 by 2. So c should be minus 1 by 2. Why? Because okay, so listen to me carefully. At some point x should be equals to 0, right? At some point x should be equals to 0. So maximum value of this term will be minimum value of this term will be minus 1. So minimum value of this term will be minus 1 by 2. And at that point c should be 1 by 2, then only it will cancel. Minimum value of this x will be 0. This 0 is only possible when sine should be value of sine should be minimum. Value of sine is minimum when value of sine will be minus 1. So minus 1 by 2 plus something should be 0. So something should be 1 by 2. Okay, so I think I confused you guys, so I am rewriting it over here. Okay, so my idea is 1 by 2 sine 2t plus phi plus c. Now I know minimum value of x should be 0. Okay, this SHM is varying from 0 to 1. So x is equals to 0 when this term should be minimum. This is constant. Minimum value of this should be minus 1. So minus 1 by 2 plus c should be 0. So c is equals to 1 by 2. Okay, so I am rewriting again this equation. So x is equals to 1 by 2 sine 2t plus phi plus 1 by 2. Okay, now what should be the value of phi at t equals to 0? At t equals to 0, position x is equals to 1 meter. Okay, so t equals to 0, this should be 1. So what t equal to 0, this will be 0 and this should be 1 by, so phi is pi by 2. So x is nothing but this, x is equals to 1 by 2 sine 2t plus pi by 2 plus 1 by 2. This is the function of x with respect to time t. I hope everyone is clear. So let me rephrase. Okay, so first what we did, first we compared this equation with the horizontal spring mass system. Okay, so this term is indicating me towards the SHM and this term is indicating me the constant gravitational force. Okay, so it gave me hint. Okay, minus 20 is nothing but minus kx and 10 is nothing but kind of mg, some constant force. Okay, some constant force C. So just by I know this is how vertical spring mass system looks like. So I wrote the solution. I wrote the generic equation. It looks like x is equal to a sine t, x is equals to a sine omega t plus phi plus constant. This is generic term, okay, generic SHM equation. And at t equal to 0, acha, okay, now after comparing with some values like equilibrium position and extreme position, how we figured out extreme position? Because it was given extreme position was x is equal to 1 meter. How I figured out this is extreme position? Because it was at rest. Since it at SHM only this happens, that at rest it is extreme position, okay, and in the equilibrium it has the maximum velocity, and at extreme position they are at rest, so velocity is 0. So x is equals to 1 by 2 is equilibrium. Why it is equilibrium? Because force was 0. X is equal to 1 was extreme. Why it was extreme? Because it was at rest. So one equilibrium, I know one of the extremes, so definitely another extreme will be in the opposite direction with the same magnitude. So I got the value of A as 1 by 2. I got the value of A as 1 by 2. Omega, we know omega is root k by m. Just by comparing we can say k is 20, I guess. Yeah, k was 20, the coefficient of x. So k was 20 and mass was given, so I figured out omega comes out to be 2, A is 1 by 2, and by simple mathematics the extreme position should be 1 and 0, okay, and if maximum value of sine will be 1, so 1 by 2 plus 1 by 2, this is 1, minimum will be minus 1, so minus 1 by 2 plus 1 by 2, minimum value will be 0. So this term is satisfying my conditions, okay. So this is the how what is happening, this is how our position is varying, okay. Now how can we figure out velocity? Yeah, we just have to differentiate it. So velocity is nothing but dx by dt, and if we differentiate it, what we will get? 1 by 2 ka differentiation is 0, so and 2, so cos 2t plus pi by 2, okay. So I got the term of velocity, I got the term of acceleration, and yeah. So what was the question? Question was we have to figure out the position and momentum at t equals to pi by 4. If we will put t equals to pi by 4 here, at t equals to pi by 4, if I will put t equals to pi by 4 into 2, which is pi by 2 plus pi by 2, 9 sine pi, right? Sine pi is nothing but 0, right? Sine pi is 0. So x will be at t equal to pi by 4, x is equal to 1 by 2. If I write t equals to pi by 4 here, so what will happen? 2 into pi by 4, which is pi by 2 plus pi by 2 again pi, so cos pi is nothing but minus 1, so velocity will be minus 1. So x is equals to 1 by 2 and velocity is equals to minus 1. This is the answer. So according to me, okay, I forgot the answer. 1 by 2 and minus 1. 1 by 2 means B and C. Acha, we have to figure out the momentum. So okay, 1 by 2 and 1. So if I multiply with mass, 1 by 2 into mass into velocity was minus 1. So C is the answer. I hope you guys enjoyed the solution. So basically here there were the two approaches, okay. So one was the mathematical way, which I have not went through because I do not know the scope of mathematics for the JEE Advanced syllabus, but as far as I remember, the classical way of solving differential equation, double differential equation, is not in the syllabus. But there was another approach. What we can do, we could have just simply imagined it in the vertical direction, and we can say like, yeah, it looks like a vertical spring mass system, okay, where spring has a spring constant of minus 20, and instead of constant gravitational force of mg, the constant force was 10. Or we can also say, instead of being in earth, we are we are living in some planet where gravitational constant has value of 2 meter per second square. Okay, so I hope you guys enjoyed the question and the way we have approached it. So let's meet at the third video. Let's meet at the next video, which will be the fourth one. Okay, so stick to it. I personally believe if someone will go through all the series or all the video of this series, they will be very confident to solve the kinematics question in JEE Advanced or in any question, any competitive exams. Okay, thank you. See you in the next video.